is
Shit.
okay. We've broken that down. Broken the barrier. Um, you want to add a fuck?
Fuck.
All right.
Yeah,
All right.
we're done now.
All right. Uh, so Johnny Garrett, who is another of our lead engine programmers, leading the animation, what we call the animation team, but
Yes.
animation slash cinematics slash
Audio.
audio slash
Physics.
physics and other stuff.
Yeah.
Right.
Yeah.
Anything you want to add about the team and how you work yourself?
How what? Say that again.
Anything you want to add?
I mean, that is the name of the team, and they're the things we do. I guess.
What can? Okay.
Shit.
All right, Johnny. What connects all these things for you?
They're basically all the things that make things move and make things give feedback to people in the game that aren't the things that render the things in the game. If that cleared anything up. So we're not rendering, but we're doing all of the low-level stuff that facilitates the game to, characters exist in the world, characters move around in the world, characters interact in the world, characters make sounds in the world.
So for me, I like to think of it as sort of all the sort of DSP-like stuff, right? All the sort of signal processing like things, right? I mean, for me, mentally, that connects between animation and cinematics and audio,
Yeah.
And physics even, right? It's all the
Right.
sort of signal processing that's happening,
Yeah.
of varying complexity.
Yes.
All right.
That's another answer.
So can you tell us a little bit about how, let's talk about a little bit about each system. How would you characterize our animation system? How does it work?
It's not. I mean, it's similar to existing, or it has commonalities, I guess, with how other people approach things. The sort of not at the low level necessarily, but we have these things called anim drivers that kind of characterize or are responsible for or tied to one game state. So an anim driver might describe or be responsible for animating the character in an idle state or a move state or a death state. So we have this thing called an anim driver, outputs an anim tree, which is a bunch of nodes connected. We have a thing called an anim controller that wrangles multiple anim drivers. So the anim controller is responsible for, it kind of activates the drivers as one thing blends in and another thing blends out. It handles those blends. So each driver's outputting an anim tree. They kind of output into the structure, and then we just stuff a blend node at the top, and that blend node, the blend interval, blending between one branch and the other branch of the tree, that's handled by the anim controller. Then kind of when that blend's done, we've gone from, we were in idle and we're going into move. Idle has blended out. We kill that part of the tree and we're just focusing on move.
But idle, for instance, that driver is not just a simple the idle animation, like a full body animation, right? It's itself this whole tree,
Yes.
right? So how is that described by animators? How does that work?
So we have a node-based editor, anim set editor, that edits the drivers themselves. So the drivers of these collections, it's a DAG, collection of nodes. The leaf nodes in the DAG are things like, effectively clips. That's the only real leaf node is a clip. We have two kinds of clip. A regular clip from Maya, or what we call a performance clip. A performance is it's like a procedural, for procedural lip sync or procedural facial expressions, and as I'm talking, kind of gesticulating, the body gestures are also defined by this performance clip. So they create clips, create blends to blend between those clips. Other things such as they can mirror directly in the tree, so big on fuse, if you guys holding or peering behind a wall, with the rifle in his right hand, and you switch and his peering, he changes his to be the other-handed. We add a mirror node in there and select between one branch of the tree that's not mirrored and the other branch that is mirrored, and it it'll dynamically add a mirror to the current tree based on the state of the game. So yeah, I think that kind of summarizes the drivers.
So what were your goals with the system in the first place? Like, what were you trying to accomplish?
It was a big deal, was kind of getting, we wanted to, the word I was going to use is empower, but it sounds really trite, but basically that's what we wanted to do. We wanted to empower content creators, ultimately animators and gameplay programmers really, empower those guys to be able to focus on the kind of nuances of the animation, and it not be that an actual programmer had to be in there to do the thing. So the programmer knows about the drivers, he doesn't care about what things are in the driver. So the complexity can be built into the driver, and you can iterate at that level and just improve things. A basic driver could just be one clip, but a more complex driver could be 10 clips, a bunch of blend nodes, some mirror nodes, to do more complex things than, like, you could have a driver, we had a driver that's an aim driver, kind of does a sweep, get this 180 degree movement of the character. If all you're doing is blending, like, a clip that does this and a clip that does this, you can technically aim in any direction, but it doesn't look believable. Like, if you're kind of aiming down, there's things in the body that, like, pivot over the spine. So as the spine goes over, your shoulders will change, and doing those things in the graph and driving inputs from gameplay into the driver graph allow the animator or possibly gameplay programmer to blend in other clips that tilt the spine or change the shoulders, or do some subtle type thing that ultimately the game doesn't care about. He's just caring about we're triggering these things, and the end result is the gun's going to be pointing over there, but it looks nicer because people in production can iterate on that stuff.
So the goal was really to get the people who are working on the animations to be able to iterate as quickly as possible without requiring other people to help them, right? Yeah. How successful would you say you've been at that?
I think pretty successful. The purely from an iteration standpoint, there's improvements that we can make, and we're working towards that. But I think the actual end goal of they can express in the driver the things that they want to do, and they can get the control that they want. It pairs nicely the creative side of the animators, and they all, generally work really closely with gameplay programmers. They're the ones going to be providing inputs that they can effectively switch on or use in the graphs. It works out really well.
So where is the future going? Like, where do you see the future of not just your team's animation system, but the future of animation?
I mean, there is some of the stuff you talked about earlier, like the procedural animation is, pure procedural animation. You just kind of create this guy, he's a biped, set up some rules about how his joints work and set him off, and like some expert system runs, and it kind of iterates, and ultimately you're going to converge on this thing where this guy can walk around and walk upstairs and interact. In theory, that's possible, but in practice, I don't know if you've seen any of those things, but they're not. For one, they're not engaging in a kind of creative way. Technically, the guy walks up the stairs, but it kind of looks like he needs to go to the toilet when he's walking up the stairs. That kind of deal. It's not an elegant or an artistically yet. Technically can move around, but not in a very nice way. And also, if everybody's kind of doing that, you have less of an opportunity for the creative people, such as the animators, to actually give put their input on how that thing's going to look. Everything can potentially look the same, and that's not necessarily what we want.
Well, what about in a similar way that we're seeing with on the texturing and art side, sort of an animator guided procedural model?
Yeah, and we can also do Some of that stuff already count with like IK, Ragdoll, sort of procedural, but inputs to that system have been created by the animator up front. They kind of know, they don't know the actual thing that they're going to get out, but they know they have provided those inputs to give a response that's in keeping with what they want. So
I think one of the problems and sort of one of the hopes in looking at procedural generation is, the time-consuming nature of creating animation itself, right? We're looking at bigger and bigger games and open world games with more and more detail fleshed out, more people with dialogue and all the things, right? There's just a massive amount of actual animation that needs to be created, and that's not getting any less. Like in 5 years, we're not going to be making less animation in the world than we are today, right? So what's the hope in terms of sort of handling that load?
I think maybe reducing the amount of time that they spend creating unique things. We can maybe do something to allow automatic selection of a thing ourselves. Like we can build inputs to the system offline, and that can allow us to select ourselves the best thing at runtime. They can provide the input data, but they don't have to necessarily orchestrate all those things together.
Right. Let's take a minute to talk about cinematics as well. What sort of, can you give us what were your goals with the cinematic system in particular?
So cinematics kind of wrangles pretty much all of the game systems. We want...
This is a runtime cinematic system.
Yeah, runtime cinematics. Previously on, I think, PS2 Ratchet, we effectively rendered in engine, but we frame grabbed and then stitched them back together again. The new stuff is everything's runtime in the engine. So the idea is, well, for one, characters animate. So that's kind of your baseline. Characters animate, cameras animate. You also want to be able to animate as many things as possible in the scene. So the camera itself, that position rotation of the camera. You also want to animate all the parameters on the camera. The FOV, DOF. You want to animate things like material graph or material inputs on models. Potentially you want to expose those. You want to expose things like event triggering, so you need to be triggering audio. Pretty much any post effects, all those things. You want to, things that aren't necessarily in the game exposed to be animated, the cinematic system wants to be, you want to be able to create curves and drive pretty much anything you want. So I guess going in, it was previously we did, you can animate characters and cameras, and then everything else was this fallback to anything else you want to do, you do an event. An event is just, it's that catch-all for, it's an arbitrary blob with a gameplay-defined payload. It's sort of flexible in the sense that, whatever you want to do, you just create a new event. It's just there on the timeline, but it's not really good in terms of you don't have information about, maybe there's related events. You don't have any information about dependencies between them. And so when we rewrote the system, we wanted to have all these different types of track types, different things you can animate in a cinematic, and allow content creators to easily animate directly in the tool or animate in Maya and provide that input to the tool. Fast iteration, I guess, that's a key thing across the whole tool suite, is be able to iterate fast, but it was particularly important for cinematics.
So I think, from my point of view, the two big problems in cinematics have been camera cuts and time.
Yes.
In the sense of that the actual clock that's driving cinematics. What are why are those two problems in particular surprisingly difficult?
Yeah, in hindsight, we'd definitely do it differently in hindsight. But two things that caught us out. For camera cuts, so one thing for camera cuts, characters and the camera move between cuts often. Often, if this thing is mocap driven, they don't do the shots necessarily at the same time. They don't grab the shots necessarily at the same time. So the actors are in different positions, or sometimes maybe they did a shot and they were in the same position, but they cropped something off the start of the shot. So now one guy, ended one shot in this position, and in the start of the next shot, he's 2 feet forward. So one of the things that catches you out with is instantaneous teleportation of characters. I mean, the game does teleport characters now and again, but it affects things like cloth settling. You know, you can't just change character position in one frame and expect the cloth to be in a settled position by the time you kick off that new shot. Another thing that, I mean, they're all ultimately bugs, but another thing that caught us out was the fact so the game's not updating at integer frames. It's updating at float frame, and we have a float DT that we step time with. So any point in time, in terms of kind of sampling of an animation track, we're always sampling 2 frames that straddle the current frame, and then we have a subframe interpolation that interpolates between frames A and B. So if it happens to be that on the current frame you are less than a 30th of a second away from the end of the current shot, and then the next shot you're going to be some way into the start of the new shot, if you don't look out for it, there's that potential that you're going to interpolate between the end of shot 1, where the character is like where I am, and the start of shot 2, where it's 2 feet away, and you're going to get that subframe. It's just 1 frame, but motion blur, and you see everything like interpolate for 1 frame. That was another one. Another one is that deal of float frames versus int frames. Maya does not do subframe interpolation, so it's just ticking at absolute integer frames. So one of the things that we do is the animators will animate the cinematic, and then they'll create a play blast, which is a quick render out of Maya of all the shots one after the other. Between shot A and shot B, there is effectively 1 frame that we throw away, because each frame lasts for a 30th of a second really. So it's these stitched together lists of 30ths of a second. There's 1 frame between the end of shot A and the start of shot B that doesn't really exist. Maya doesn't interpolate that frame, so it doesn't matter, but for us, we do. So what we did end up with, was you have a cinematic with 100 shots. There's 1/30th of a second times 100 that we've missed, because we're dropping that frame and Maya never evaluates that frame. So they'd do a play blast, and when we ran and they'd time things out, when we played that back in engine, and they would often have created music or an audio score that was exactly timed to the duration of the cinematic, we'd end up being less by 100 times a 30th of a second, which adds up. So we had to our creative solution for that was we take that 1/30th of a second for each shot and basically dilate time by a 30th of a second divided by the number of frames in that shot. So it's just slightly, minusculely slowed down or sped up. So they were big things.
I know that sort of in terms of the tools, the cinematic tools themselves, right? One of the complexities is that as I'm editing a cinematic, right, naturally I want to scrub it backwards, right? I want to go forward and backward along cinematic. And when you have a cinematic that's a runtime tool, and it's talking to all the game systems at runtime and triggering off events and getting, AI and things to move around and triggering off animation and effects in particular, right? That all these things that aren't designed to run backward, right? But all that still has to be managed properly in the tool, right? It still has to be sort of understood by the people using the tool so they can build the cinematics. How is it that you manage that problem?
Well, animation itself is pretty easy. It's basically, if anything's like effectively a continuous function where you can jump into an arbitrary point and just evaluate at that point, then we're good. Animation, joint animation in general, camera animation, those both fall under that. But things like our particle system, at least, does not have a jump into an arbitrary point in time. If you roll back in time, we can't just rewind and be at that specific point. So we do things like trigger from the front and wind time forward up to the point of the scrub, where the scrub line currently is. Or there's other things like triggering game events. Often game events are, they have an effect on a thing in the game. So a game event might be hide the guy's weapon. If you play that forward in game, it's fine. You go in, the guy's got a weapon, you trigger that event, the weapon gets hidden, and then you're back in the game and the weapon should have been hidden. but you need to add support to know that some things we explicitly need to be able to undo these things. So if we backtrack over a hide, we need to know that there was an undoable event there. So we cache off that this thing, we have support disk for caching off things that we are aware of that are things we want to be able to undo, and we'll explicitly, what do we need to undo to get back to the state that we've just backtracked to. And that's Bink is another one. We have movie potential to play a movie. It's often, or the use cases, like an intro sequence, and there's some offline rendered, like a dream sequence or something in some quads displayed on the screen. You want to be able to scrub that. Most movie players are not meant or not designed to arbitrarily scrub back. They're designed, 99% of the time, just scrub forward. So there's a few hoops to jump through there where you can't expect to just jump. You don't get the same fidelity of, slide around on the timeline and get the same feedback that you would with simple things like animation.
Where do you see sort of, in terms of runtime cinematics in particular, where do you see the future of that going?
I mean, we're looking to do, other games are doing it already, but things, you want it to leverage AI code as well. We don't necessarily just want to have everything be, it's completely orchestrated in Maya. I mean, for one, it's a big, there's a large time investment there. And for a lot of other things, we want to kind of build on the fact that characters already know how to run around and interact in the environment. We want to leverage being able to trigger AI. So building in support for maybe targeted AI, like not just go here, and he's like, I didn't want you to go that way, I want you to kind of go this way, but I don't want to animate it. Hinted AI, where we can lay down stuff that drives ultimately the decisions that AI is going to make.
All right. I wanted to ask you also about leadership on the team. What are the things that you found sort of most difficult about being a lead on the team?
It's I've had time with one sort of, I guess, delegating tasks. Like, personality-wise, a thing will come up, and I'm often one to jump. Oh, crap! There's this other, there's another fire come up. And to me, it's like we only really hear about fires. We don't generally hear about, things are going okay. You don't need to worry. So they only ever shouting at us when there's a fire. There's a lot of fires. We have 5 games running. So things come up all the time. As soon as a thing comes up, it's like, shit, this person can't work. If a person can't work, that's the real, we have to drop stuff to get this person working. It's not okay for the tools to take down somebody else and they can't work. So personally, I find it hard to not myself just jump onto that, even if I'm just kind of thinking through, what could the cause of this thing be? I'm not actually necessarily debugging it, but even that, what could be going on here? So I can kind of assign that thing to somebody on the team that could work on it. That right there is still a context switch. So I struggle with things like trying to juggle. It's like, those plate juggling thing on sticks. It's like a bunch of those just spinning, and you're trying to keep them going, and then there's still the work that you yourself are trying to do. So I have a number of things in the engine that I'm responsible for, and I'm still trying to juggle the time of how much can I effectively spend there versus working with other people to work on those things.
So is there any advice that you would give to people as other leads of technical teams?
It would be, I think one way to look at it is if ever the question comes in your head, should I delegate this thing? Or could I delegate this thing? Then it's kind of, that's the decision made right there. That thing needs to be delegated. You should look to get as much stuff off your plate as possible, even though it's often not an easy thing to do, especially if you've birthed a system, you've got that, I don't necessarily want to give my baby away to somebody else. So there's, it's not practical for a small number of people to be working on such large things. We have, a ton of experience in the team, and that's what we want to do. We need to share that knowledge and kind of approach these problems as a group instead of as individuals.
one of the things that we sort of ask of everyone on in the core team, regardless of their position, is that they're sort of their champion of something, right? That they are demonstrating leadership in some area. And for you personally, the area that you've sort of been the champion of is keeping things as simple as possible.
Yeah.
What have been the main challenges in doing that?
I mean, working with a bunch of legacy code, I think that thing came from, for some things over time, worked on these things for a number of years, and things get fixed or edge cases get patched, and, that beautiful piece of code you started out with when you first created this thing is now a bit of a monster a few years later, with a few people having kind of been, punching it into submission. So there's often, your code is not quite what it was, and it has a bunch of edge cases, and it's hard to reason about. If code's hard to reason about, well, two things that are bad with code that's hard to reason about. One, you spend time, bug comes up and you spend time trying to be like, oh crap, what, how did this work now after all these things have been patched onto it? So it's time sink right there. On top of that, maybe you don't fully understand it after you've thought through those things, so you add a fix. If this thing's already like a bit of a house of cards, you've potentially added another bug because you weren't able to fully or clearly kind of think through what's the model of this thing now. So we've been hit by both of those, things that have become messy over time, and then we have introduced new bugs because this thing's such a hard thing to reason about.
Right. I mean, part of the thing with sort patching things over time and figuring out, is really sort of a discovery of what the system is supposed to really actually do, right?
Yeah.
That
totally.
your original model was wrong.
Yeah.
So
right.
whatever you thought was your sort of your clean code at the beginning was actually just wrong because it didn't support these things.
Sometimes it can also be other requirements changed. We've got to patch, we've got to add this support on, which I guess could be your understanding of the requirements was wrong.
Right.
I mean,
or wasn't sufficient to do what you actually wanted
to do now.
Yeah. So this is about sort of that the problem much better at this point, right? That you have this history and that you can start over and learn what all the new things you missed were, right?
Yeah.
So it takes some time to sort of burn down that technical debt.
Right. Yeah, exactly.
So in terms of the sort of the balance of taking time to do that versus we're sort of working on new issues or fixing bugs directly, where do you find that balance? Like, how do you decide how much time to spend on it?
It's maybe, there's not a scientific way. It's just kind of, you get to that, this thing, we've been pulled back into this system, and I don't know, gameplay can't reason about it, or it's catching out either gameplay programmers or production people, and ultimately we get pulled in to debug why this thing that maybe is a setup issue, or maybe it's a bug that we have. It's kind of like anytime we get pulled into a thing and we are back into supporting this thing, it's like we don't want to go near that ever again. We want to, carve out some time, potentially refactor a thing, simplify it, get it to where everyone on the team, we all understand this thing. That's another thing often. This thing that's a large part of the system, the person that was the main developer on this thing is not there anymore. So it's like we kind of get what this is, but we don't really. It's an opportunity to simplify that system and get the knowledge shared back out to the team, and ultimately be, we don't want to spend time supporting this anymore. We should be spending time on new things or extending things rather than patching issues with old things.
Well, I think that's an important point, right? I think a lot of times good stuff comes from not just saying how could this be better, right? When we're saying how we're supporting a system, how could it be better? How could we spend slightly less time supporting the system? How could we make it slightly cleaner? Really, I think the value comes from asking that question of, from saying, I don't ever want to do this again, right? Trying to figure out how to make the problem go away entirely, right? Yeah. So it's now a commodity problem, so we're not doing, we're not focused on it ever at all until something new comes up, right? All right. Finally, one of the things that I think is common to a lot of busy teams is sort of managing a backlog. You have lots and lots of requests and lots of things that get piled up over time.
Yeah.
How do you manage it?
Poorly might be the one-word answer to that. I mean, we have like an overwhelming number of tasks. An overwhelming number of tasks. So all these things come in, and often, personally, I'll often write them down on post-its, and I have this sea of post-it notes on my desk that is, I know it's not really that good a way to do it, but often I'll get to a point, I'll be like, there's too much stuff, and we'll convert this thing.
Throw all the post-its on the floor.
I effectively do, but I've written up a note or created a bug. There's a bug in DevTrack for this thing. Sometimes that works well. Sometimes it doesn't, because I'll often assign those things out to people, and then they'll be like, all I've basically done is typed up this scrawled 3-line post-it note thing that makes sense. Do the thing about the stuff, and I know exactly what that is, but other people are like, how do I do this? So that's one issue. And then also you get that thing of, in DevTrack, there's like 2,000 things over 5 pages of stuff, and that's a really hard thing to. You can't like take a step back and be like, okay, how are we going to prioritize these things? So I mean, a lot of the time it's just get things. We want to get things into people's individual lists where it's like we don't really need to think about this now, but we're kind of going to want you to start thinking about this thing, and keep that 2,000 list thing. That's not a workable thing, so keep that manageable, and that's effectively, do we really need to do? No, that's gone. So
be super aggressive about taking stuff out.
Yeah, and I've had time with that 'cause I'm like, oh, I'm really sure this could be a thing, but I thought this could be a thing 3 years ago when I added it. It's like, this is probably not going to be a thing, so just get rid of the thing.
Yeah, so I think as a rule of thumb, if you feel like you're not going to get to it in the next, say, year, don't even put it on the list. Right. Just cut it off, right?
So I have, and I'll, make a few passes and get rid of those things, and then I have my own, a notepad basically of a bunch of crazy ideas, and it's like, there's lots of stuff in there that maybe I'm fooling myself that I'm going to go back and look at these things at some point, like, oh yeah, that was a cool thing. But at least I'm not just thrown it away. Mentally, it's still there in this list.
All right. Thanks, Johnny, for your time.
Cool.